Welcome everybody. We will now talk about thermal design and analysis of PCBs. My name is Michael Harrach. I'm a physicist. My background is that of in solid-state physics originally. I got my PhD at the University of Darmstadt and I joined CST in 2015. And as of the moment I am a member of the T&M team, T&M supplier team, and an industry process consultant here at Simulia. So, thermal design and analysis of PCBs. We have, of course, a multi-physics studio within CST, which allows us to do, for example, thermal simulation. And the nice thing is simply the seamless link that we have between the different options. So whether we are in PCB Studio, in Microwave Studio, in EM Studio, or whatever, we can simply take the losses that we simulate there, put them over to Multiphysics Studio, and get temperature distributions. And if we want to, we can also, in part, transfer the temperature back, update material properties based on that, and recalculate losses, recalculate temperatures. Now, the latter option with regard to the bidirectional coupling is something we do not have at the moment with regard to PCB Studio. So when we're coming from the IR drop, we can only do unidirectional simulation, or unidirectional coupling, I mean. What can we couple to? Well, we have the classic thermal solvers, steady state transient, THS and THT. The classic thermal solvers are conduction-based solvers, and if you want to incorporate convection or radiation effects, we do this by setting up thermal surface properties and supplying coefficients like convection coefficients and reference temperatures in order to gain or lose the heat that we would gain or lose via convection or radiation. Then we also have the conjugate heat transfer solver. And since 2021, or in the coming 2021 version, we will also be able to do transient simulation with the CHT solver. In 2020, we are still only able to do steady-state simulations. Here we explicitly solve thermal conduction, convection, and radiation using CFD. So we can solve the spectrum of physics that we will be up against, so to speak. We have laminar and turbulent flow. We also have multi-fluids. There is a 2R model. We can do flow resistance. So there are quite a few options available there. And of course, we also have a structural mechanics solver, which admittedly is rather limited in its application. Now, I have already mentioned in version 2021, we will also be able to use the CHT solver for transient simulation. So how does the typical EM thermal coupling workflow look like? Well, of course, we first set up the model either via import, for example, using the EDA import. We then select the solver type and simplification level. We have to get the losses from one of the EM tools. We have to add thermal and flow properties in order to set up the whole problem. Do the mesh, simulation parameters, possibly acceleration settings. The CHT solver can use GPU acceleration, do some post-processing, and of course visualize the results to take a look what kind of temperatures we actually do have there. So how do we set up? Typically when we're coming from Microwave Studio or low frequency, for example, we would be able to use the EM thermal coupling. And we cannot at the moment use this coupling mechanism yet